Genius Hour by Nathan Brown. How will Mars homes look? Today I'll teach you why they'll look something like this. The planet comparison between Earth and Mars. Mars is almost 2 times smaller, it weighs much less, and it has a longer orbit. At its farthest, it's 1.6 astronomical units, and at its closest, it's 1.4 astronomical units. Either way, that's much farther than Earth. The gravity on Mars is 3.7 meters per second squared, which is over half less than on Earth. The pressure is 0.6518 kilopascals, and just for comparison, on Earth, it's 101,000 kilopascals, so it's really low pressure. The atmosphere composition is 95% carbon dioxide, compared to on Earth, where it's 21% oxygen. And finally, there's a drastic difference between the temperature. The temperature on Mars is negative 62 degrees Celsius, compared to on Earth on average, which is 14 degrees Celsius. So if we want to live on Mars, there's going to be a few challenges we're going to have to engineer around. Other facts about Mars is winds can reach up to 100 kilometers per hour. Mars has a weak magnetosphere compared to Earth. Mars has very rocky terrain. There's lots of dust and often dust storms. We'll have to engineer around that too. So here are the engineering challenges. We'll have to plan around air pressure in the home, heating and insulation, cosmic ray protection, in-home exercising, in-home farming, dust prevention, and our doors. Air pressure. The atmosphere for Mars is not suitable for human habitation. The inside of the homes must be pressurized with oxygen. The high pressure will cause a strain on the structure of an ordinary building, such as ones that we live in right now. So we'll have to have a special building. The formula for pressure is equal to force over area. We can get a high volume to surface area ratio with the shape of a sphere. Compared to any other shape with the same surface area, this sphere has the highest volume. The constant curvature also makes the force felt on the walls constant and no points of strain. This concept is demonstrated by the shape taken on when a balloon is blown. The balloon takes on the optimum shape to reduce force and stress on the rubber. Heating and insulation. Mars is very cold compared to Earth. We'll need to engineer to not only warm the house, but to also keep it warm. To warm the house, I propose that not only to have in-home heating like on Earth, but also a glass sunroof at the top of the home. This would make the home almost like a human greenhouse. We also need to make sure the home is insulated to retain heat. We may be able to use some resources from Mars for the walls to reduce weight at launch, but it's more feasible just to bring insulation to Mars. The main material on Mars is basalt rock, iron, nickel, and silicate. This can be used for the walls. So, on Mars, we might be able to dig up some of the rocks and make a 3D printing facility to 3D print these houses to get the optimum shape, as stated before. However, rock has a high thermal conductivity, and on Mars, the estimated heat loss for rock is 4,000 to 8,000 watts. Instead, I propose we bring a lightweight insulating material such as fiberglass or even reuse the insulation material from the spacecraft. The thermal conductivity of fiberglass is 0.01 watts per meter per Kelvin, compared to rock, which is 4 watts per meter per Kelvin. Using the planet's silicate, it may be possible to create foam glass in situ, but infrastructure must be made so it isn't viable for the early stages of colonization. Foam glass has a thermal conductivity of 0.038 watts per meter per Kelvin. That's what we might have to bring in the spaceship. We can heat just using normal heaters, or a more innovative method proposed by Elon Musk is to have satellites in Mars orbit with reflectors pointed at the colony. Focusing the light onto the colony is a way to possibly heat up the homes. The extra light energy will heat up the air inside the home. So we might have that orbiting Mars and shining on our homes. Cosmic radiation. Due to the lack of magnetosphere, there's a higher concentration of ionizing radiation hitting the surface and our future homes on Mars at any given time compared to Earth. To work around this, we can have thicker walls and we can use coatings on the wall and glass to prevent these rays. This is the most challenging problem at the moment for Mars colonization. So we can't limit time. These are the steps on Earth to reduce radiation. We can't limit time because we're going to be there forever, so we can't do that. We can't increase distance because our distance is basically determined just by the distance from the sun. Can't do that. But we can use shielding by getting thicker walls and maybe putting some reflective coatings on our walls. Ding, ding, ding. In-home exercising. The gravity of Mars is much lower than on Earth. The lower force will cause our body to adapt and use less nutrients and strength in our bones and muscles. This will cause weakness when in the gravitational fields of Earth, making it almost impossible for a Mars habitant to return to Earth and have the strength to function. It is not feasible to bring a bunch of weights because it will increase the spacecraft's load, so instead an engineering solution is to use tension exercises. We can't just bring a bunch of weights because not only will it make the launch way more expensive, but say a 50 kilogram weight will weigh much less and have less force on Mars than it would on Earth, so we'd have to bring even more weight than expected. I propose each home is equipped with one master tension band, which is connected to the ground, and then using pulleys, the master tension band can be equipped to different machines. This is much like the concept of a Bowflex. You have a pulley system and you attach it to the tension, and you could use multiple exercises using the one master pulley. In-home farming. We will need a sustainable way to get food. The most simple way is to farm. For plants to grow, they need light, water, and carbon dioxide. We can have a growing room at the top to use the sunlight for growth. We must make sure the glass is UV and ionizing radiation proof because those radiation wavelengths have the ability to alter DNA. Changing the DNA in the plant will have harmful effects on the plant, making it so it might not be able to grow and wilt. We'll have our own greenhouse in space. Dust prevention. Without dust prevention, due to the constant dust storms, our doors might get blocked up. I propose a mesh airfoil system surrounding the home so majority of the dust gets caught in the mesh. The mesh is required or else a pressure difference will build up under the foil and preventing the dust from getting caught instead of forcing it over the foil. The door. The final issue would be getting in and out of the home. A normal door would release the pressure. I propose an airlock system equipped with an air pressure regulator. A room with two airtight doors, and depending which way you're going in, an air compressor or vacuum will fill the room to the correct pressure. I will make my airlock intruding rather than protruding just to keep the overall shape and sleek design of the home. That's what an airlock looks like. And thank you for watching. To learn more about Mars homes, visit dqugb.weblium.site. And that's it. Thanks.